In this video, we're going to work through the first page of Notes 3.4. And what we're going to do is we're going to learn some new tools that will help us to find zeros of polynomial functions when we cannot factor or where we don't know, we're not given any factors or zeros, so we can't start with longer synthetic division. So I'm going to read a bit. In section 3.2, we found zeros of polynomial functions by factoring. In section 3.3, we used long and synthetic division to verify zeros or factors and to reduce a polynomial to degree 2 so that we could find all zeros or completely factor the polynomial. But what if we have a higher degree polynomial function and a method to factor is not obvious? In today's lesson, we'll learn some techniques to help us find all zeros by hand. So as a quick review, we know that an nth degree polynomial function has exactly n zeros. Using this statement, we know when we found all zeros, right? If it's a fifth degree polynomial function, we need to find 5 zeros. Note, this does not mean that an nth degree polynomial will have n distinct zeros. Remember, zeros can be repeated. However, if we count repeated solutions or zeros or roots, the number of times they occur, then an nth degree polynomial has exactly n zeros. Okay, so what is this new tool? So the new tool is called the rational zeros test. And what the rational zeros test says that if we're given a polynomial function with integer coefficients, then the only possible rational zeros for that polynomial are of the form p over q, where p and q have no common factors. And what are p and q? P is a factor of the constant terms, so factors of a sub 0 are p, and q are factors of the leading coefficient. So q is going to be factors of a sub n, or the leading coefficient. So to put it in other words, the only possible rational zeros are factors of the constant term, so factors of the constant term divided by factors of the leading coefficient. Not all zeros are rational. Remember, some can be irrational and some can be imaginary, right? So complex. So some might be complex. So the rational zero test only helps us find past possible rational zeros. It won't help us find all the zeros, but it can be a starting point. So how does the possible rational zeros test work? First, in example 1, we are going to list all possible rational zeros using the rational zeros test. So the rational zeros test tells us that the list of possible rational zeros are going to be of the form p over q, where p are going to be factors of the constant terms and q are going to be factors of the leading coefficient. So p in this case is 3. The factors of 3 are plus or minus 1 and 3. The factors of q in this case is 4, its factors are plus or minus 4, plus or minus 2, and plus or minus 1. And now we can go ahead, and when you're asked to find all possible rational zeros, you actually need to list them out. You can't leave them in this form. So I'm going to start listing them out. So I'm going to take the first factor, so plus or minus 1, I'm going to divide that by 4, 2, and 1. So I'm going to get plus or minus 1/4, plus or minus 1/2, plus or minus 1. And then I'm going to take the second factor from the numerator, which is 3, and I'm going to start listing the zeros. So I'm going to have plus or minus 3 divided by 4, plus or minus 3 divided by 2, and plus or minus 3 divided by 1, which is just 3. So I would probably just write that last term as plus or minus 3. And that is the list of all possible rational zeros for this polynomial function. Let's try example B. So here we need to figure out what p is. Remember, p are factors of the constant term. So the p is -6, and we're really interested in factors of -6. So that'll be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And q is the leading coefficient, which here is 1. So the factors of 1 are plus or minus 1. So in this case, when the leading coefficient is 1, the possible rational zeros are just the factors of the constant term. So I'm going to list those out. So plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Those are the possible rational zeros. So we can conclude here, that when the leading coefficient is 1, the possible rational zeros are simply factors of the constant term. And this is actually going to simplify our work in some instances, right? Because if the leading coefficient is 1, that means Q is 1. So the possible rational zeros are simply factors of the constant term because we just to be dividing by plus or minus 1.